fantastic to see that many people registered, by the way. And hello to everybody I don't know, and hello to everybody that I do know from the list. I see quite a few faces, names I recognize. Right, I still see a couple of people trickling in. Let's give it another exactly 15 seconds and then we'll get started. Perfect. According to my high technology analog clock over here, it's time to get started. Welcome to this webinar. Thank you for joining. My name is Mark Hermling. I'm the head of technical marketing at AdaCore, and I'm extremely excited to present this webinar to you here today. We're going to talk about our release 26.1, all the new features that are part of that release. And we're going to give you a couple of sneak previews here and there, and we'll sprinkle them through the presentation on elements of our 27 roadmap. So before we get started, I'd like to push a quick poll on your screen to ask you a bit of information as to what programming languages that you're using right now. If you can kind of fill that out, and at the end, I'll give you a bit of an overview as to what we found in that poll. This event is being recorded. Your video and your microphone is not in it, but make sure that you're muted and your camera's off if that's of concern to you. The slides will be sent at the end, so you don't have to take screen snapshots, but you're welcome to. And if you have any questions, there should be a question box somewhere on your screen. Feel free to enter your questions in there. I expect we'll have about 10 to 15 minutes at the end, and we'll go through the questions there. So let me give a little bit of an overview. Most of the people here, I'm sure, are familiar with AdaCore. We are here to help our customers build high-integrity software. And a lot of the development team that we're working with are under pressure. And I'm sure that you see that in your own environment as well. Budgets are shrinking, right? Either you have to do the same type of work with less people, or maybe more work with the same amount of people. The complexity and size of the software that you're working on is increasing. If you look at an embedded device today versus that same embedded device 5 years from now, the amount of content and connectivity and graphics and those type of things has exploded. And self-driving cars, for example, of course, the ultimate example of that with digital displays. And then the amount of functional safety and security concerns in those devices has gone up significantly as well. Functional safety, of course, again, if you look at the car, the display needs to be safe to a certain extent. And then security with regulations such as the Cyber Resilience Act and the investment in this CISA in the US, software development teams have to deliver more frequent updates on the software that they're working on, right? So that's what we're here for at AdaCore. We're here to help you accelerate that software development lifecycle. We have a lot of different services and products that we have to do that for you. And you can see them here all over the software development infinity diagram, as I call it. And we'll touch upon a lot of these different products today. We'll talk about GNAT Pro, our compiler offering, and Spark Pro. Lots of really interesting updates for that. IDEs, of course, are really, really important. AI, LLMs, GNAT IQ is a big topic. We'll talk about DAS. We'll talk about Code Sonar. And you can kind of see where all of these services and products are placed all around your software development lifecycle. So I'll be your master of ceremony today. From a topics perspective, this is the order that we'll go through everything. We'll talk about new capabilities added to the Ada language. We'll talk about extension of coverage for Rust, specifically focused on defense and automotive. We'll talk about fuzzing, part of our dynamic analysis suite, to explore paths through your application to uncover security issues that you may not know about just yet. Code Sonar and GNAT SAS is a big investment for us. Helps you shift left defect detection with static analysis, so we'll spend some time and a demonstration actually about this as well. Spark, which is Ada with formal methods added into it. Spark is a subset of Ada, helps you prove the absence of runtime errors and proof of correctness. Some great features there that help you take in those formal methods. And then user experience improvements with AI and IDE integrations. And then finally, we'll close off with a quick overview on AdaCore contributions to open source, as well as a quick overview of some of the things, the excellent things that our students have been doing in our academic program. So that's it. I'll be coming back to you after the presentation. I'll go through the questions and I'll give you the overview of the poll. But right now, I'd like to pass it off to the actual experts to kind of dive deeper in these agenda topics. So first presenter is Jose. Over to you, Jose.
Thank you, Mark. So I'm going to give you a very quick and brief overview of a few new things that we have added to the compiler that will help you developing what we believe is better Ada code. So one of the things I want to say is that you will have access to the slides. So you will have time to look into the details of the examples that I'm showing. I will go very quickly just to give you the main ideas of them. In this case, I'm talking about extended access. It's a new aspect that we have added so that you can create a pointer to an array slice. It was not possible before. You can have access to a piece of an array, which is typically useful when you try to use a piece of an array that has been created in a different language. Next, we will talk about things that you find today in other languages, like C++ is the finally part. Finally is a block that you create at the end of any declarative part that defines something that will execute unconditionally after the end of that block. It means that even in case of an abnormal termination because of an exception, this piece that is marked as finally, so the finalization of the memory of the message object will happen if there is an exception or if there is not. Next, a bit in the same, let's say, the same area of things that we can find in other languages is the continue. Continue provides you with the means to stop the execution of a loop iteration at a given point, but jump to the next iteration. In this case, you will skip the last part of the loop for a given iteration if the condition of the continue is true. Another thing that I wanted to present in our improvement of the compiler is to facilitate the instantiation of generics. One of the small things that we have added to facilitate the addition of a function to a generic package is to be able to specify a default expression that is being used for a function. In this case, you have a function copy, and we provide a default implementation of it. It means that you can either instantiate with another function, or if you don't specify the function, you will the compiler will take that by default. In the next slide, I will show you something again in the field of generics that will simplify the way you use them. It's basically related to the inference of formals. If you look at the top of the example, you use the unchecked deallocation generic. It will ask you for a type and the pointer to the type. Typically, as in this case, if you say that the pointer is a pointer to an integer, the compiler will obviously be able to infer that the object itself is an integer. So you don't need to specify it. You can if you want, but it is not no longer needed. Next is finally something that will simplify the creation of arrays of class-wide types. When you want to create a list of class-wide types, it's not possible because the size, for example, the size of the class is unknown. You can have a root with a given size, but all the children may have different sizes, meaning that you cannot create an array of the objects. What you typically would use is to create an array of pointers, and they will point to the specific object. What we thought to fix or to alleviate that problem is to specify the maximum size of an element of a class. In this case, we are saying that the class will have at most 16 bytes, and then the compiler will be able to create an array of objects, not pointers to that type. Finally, I will give you some ideas about how to create constructors and destructors in a way that is similar to the way you would use it in C++. That works not only for classes, for tag types, but also for records. And the way you would specify that is a very natural, very simple way to do that. And to end, I would like to help to give you an idea of something that we have done in the field of mostly targeting embedded systems. When you create a range type in Ada, the standard asks for a base type that has a symmetric range. That is being done so that you eliminate a lot of potential overflows when computing intermediate values. Sometimes if you are in an embedded system or in a system where you want to control the functions and the operations that are used, you want to say that, okay, I have a type that is a 64-bit type, and I want everything, every intermediate object and every intermediate operation to act on a 64-bit type. Then you can use the new aspect that is unsigned base range, so that you force everything to happen in 64-bit operation instead of potentially 128-bit intermediate operations if you don't do it. So that was a very quick overview of a few things that we have added. I will leave the floor now to Tony and Rust.
Thanks, Jose. Let's talk about Rust. Next slide, please. Thanks. So GNAT for Rust is AdaCore's toolchain for high-assurance Rust software. In essence, what we're doing is we're taking everything you love about all of AdaCore's existing toolchains, and we're bringing those capabilities to Rust. So we're leveraging our 30 years of experience supporting safety and mission-critical industries, building high-assurance toolchains for Ada, C, C++, and adding Rust into the mix. With GNAT Pro for Rust, you get technical support by AdaCore experts. We make long-term support available under assurance contracts, and we're certification ready. What GNAT Pro for Rust is upstream Rust, stabilized and secured. So we look at upstream Rust during the course of a year, and we pick a version of Rust that we think is going to be a good candidate to support for the entire release year. We bring that in, we build it in AdaCore's reproducible build system, we test it, and then we deliver it to you, supported over the course of that year with a warranty. We're also securing this, so we're handling software supply chain security for you with GNAT Pro for Rust. We're incorporating only known version of all of our dependencies, and we're delivering the toolchain and the libraries to you with a software bill of materials. A really great thing about GNAT Pro for Rust is if there's a critical vulnerability that's opened against one of the tools that we have delivered to you, we will take the fix for that vulnerability and we will backport it within that year so that you have ongoing support for the version of Rust that you've chosen. This is different from what happens in upstream. In upstream, if a vulnerability were to be discovered, you would have to move to a new version of the toolchain in order to pick up the fix for that vulnerability. Let's look at what's in the box. So with GNAT Pro for Rust, you get Rust C, Cargo, GDB, Rust format, and Rust Analyzer, all on the same version of Rust. So for GNAT Pro for Rust 26, this is Rust version 1.85.0. We also give you libraries, libcore, libstd, liballoc, libproc macro, and libtest. Again, these libraries are all on version 1.85.0. We include GPR Build. This is the GNAT Pro multi-language builder. So if you have an Ada application and you want to bring a Rust library into that Ada application, we've made this experience smooth for you through GPR Build. Let's take a look at the platforms we support. A key differentiator for GNAT Pro for Rust is that we make embedded platforms at the same level of assurance as the native platforms. So of course we have our natives, x86, 64 Linux, and Windows, but we also give you, with a full warranty, with full support, ARM64 bare metal. This is a no STD target hosted on Windows and Linux. We give you ARM Linux 64 bits hosted on Windows and Linux, so a Linux to Linux cross-compiler from x86 to ARM64. We give you ARM VxWorks 7 64 bits, DKM as a no STD target, and RTP as an STD target hosted on both Windows and Linux. ARM QNX8 64-bit, this is an STD target hosted on Linux. And if there's a target that you need that's not on this list, as for our other tool chains, we're always happy for you to reach out to your account manager and ask us if we can get under a contract with you to build that target to support your needs. A really cool thing we did last year is we brought Rust support to Zynq MP via a crate that we built. So this is the AMD Zynq UltraScale Plus multiprocessor system on a chip, and we've enabled Rust support for this. Our crate transforms the heterogeneous multiprocessor system on a chip into an approachable target. Currently, we support single-core applications on the Cortex-A53 core. We're looking to extend that capability this year. We've also made no STD programming better via NewLib. So typically, bare metal Rust applications are restricted to no STD. libstd typically requires functionality that's provided by an operating system. With NewLib, we're able to make no STD better by giving you support for things like standard out via printline and ePrintline, dynamic memory allocation, which unlocks box, vex, string, and similar, and program exit via exit. So this makes the experience of developing a bare metal Rust application more familiar, more similar to the experience of developing a native Rust application. In terms of availability, the Zynq MP support crate is available on crates.io, and you can find this at AdaCore-Zynq MP. That's GNAT Pro for Rust. Now I'll pass the mic on to Kyriakos to tell you about fuzzing for security.
Thank you, Tony. So let's talk about our fuzzing technology. While fuzzing is widely accepted to be an effective technique for detecting hard-to-find software vulnerabilities, and in many cases help to significantly increase an application's security and robustness, it is also well known that using mainstream fuzzers out of the box typically involves a steep learning curve and lots of manual effort. This is where GNAT steps in. It offers a fast testing solution that automates and simplifies the manual, non-intuitive steps of using fuzzers effectively. Up to this point, GNAT supported Ada and Spark fuzzing on Linux-based system, but the aim is to evolve this solution to unlock its potential in multiple scenarios, such as static analysis results validation, and to support multiple language and platforms. Based on this trajectory for the 26th release, we introduce a concept of workflows, where each workflow will target a specific use case scenario. The first workflow introduced in the 26th release is called Fuzz Everything, and it automates fuzz testing for large code bases. In a nutshell, it works by detecting all subprograms in a project that can be automatically fuzz tested, and invokes all the GNAT fuzz stages to prepare, launch, and monitor a fuzz testing campaign for all these subprograms or a user selection of them. It also parallelizes execution whenever possible to speed up the process. Then it produces actionable reports, including the project-wide global code coverage and a list of all issues detected. This has been actually battle tested with customers executing the workflow on demand on dedicated machines and has been proven very effective at capturing hard-to-find bugs in new and legacy code bases. Furthermore, we introduced support for a new test engine, the LLVM-based LeapFuzzer. This is an addition to our existing fast test engines like AFL++, Comblock, and our symbolic execution engine, the SimCC, which with each engine bringing complementary bug-finding capabilities to GNAT-Fuzz. LeapFuzzer support brings two major advantages to GNAT-Fuzz. First, it can run alongside the existing test engines on Linux to increase code coverage and the chances of exposing any existing bugs. And second, and more importantly, it enables GNAT-Fuzz support for Microsoft Windows. Although the support is in beta mode and not yet on par with Linux capabilities, for example, the Fuzz Everything workflow is not yet supported, it still brings the core GNAT-Fuzz bug-finding capabilities to Windows developers. Future GNAT-Fuzz efforts are now focused on advancing any 26 release beta features to full capability, supporting the C programming language. So far, we are able to fast test C through ADA bindings, but this support will enable direct support of the C programming language, and to support new workflows, such as assisting in validating static analysis results, as, for example, the ones produced by our GNAT-SAS technology with GNAT-Fuzz. Now I would like to pass the stage to Sean Evoy and Guillaume Riviere, who will present our static analysis highlights. Thank you.
Thanks, Kyriakos. That was great. My name is Sean Evoy, and I am the product manager for CodeSonar and GNAT-SAS. And later in my presentation, I'll be joined by my colleague Guillaume. We're going to be living on the edge and doing a live demo, so fingers crossed. All right, so what's new in GNAT-SAS 26? The focus for 26 really was on enabling the analysis of CWEs, so common weakness enumerations. And to do that, we added some new analysis types to detect the kinds of security problems that the CWE concerns itself with. The really exciting one is taint analysis. So this is the ability to detect data as it flows from an unsecured source to some subroutine or subprogram in your own program without being looked at. And we're doing that by adding new annotations. And we've actually taken our runtimes and we've annotated them. We've annotated certain key elements of the AWS as well as the GNAT call library, so that out of the box there's already some ability to detect taint, but those annotations are also available to you so that you can go and annotate your own code and make sure that you're coding from day zero to avoid data taint. This is a source of a lot of problems for programs and a lot of security vulnerabilities, so this is great to be able to detect it. Type state analysis is a new capability that's still being worked on today, and 27 will have some new capabilities as well. But this is basically making sure that you're not using something incorrectly, so that you're not opening a file twice is a good example, or you're doing things the right way. You open a file, you read from it, write to it, and then close it once. Violations of those APIs can be identified to you so that you're not doing things inadvertently that lead to different kinds of security vulnerabilities. Same thing with parameter mode analysis. Although this is a little bit more like a buddy patting you on the shoulder, this detects when you have defined a parameter to a subroutine incorrectly or a subprogram incorrectly, and gives you some suggestions that maybe this particular parameter doesn't need to be in and out because you're not ever writing to it. On the user experience front, you can now compose LKQL rules, which is great. This is new to 26. It should make things a lot easier for people to build up a composition of rules. And the new LKQL file format has been qualified in GNAT Check Qualification Kit, or the GNAT Check Qualification Kit. The new rule format is still optional. You can still use the old one, but slowly over time we're going to be moving towards that new file format. And what's really exciting if you're a GNAT Check user is that it's 30% faster now on basic code. And with generics, it's up to 200% faster. So you should see some significant performance improvements when you're running analysis. Next slide. Mark. Now, I was asked to do, what happened in 26, but what we're really excited about and what we're making a huge investment in is now that CodeSonar is part of the AdaCore family, how are we going to integrate Gnat SAS and CodeSonar? If you're unfamiliar with CodeSonar, it is an analysis engine and a web front end where you can organize, manage, and dispose of different warnings depending on how severe they are and what you want to do. So the plan here is to integrate Gnat SAS so that Ada is a first-class language in the CodeSonar web-based user interface. So you'll get things like color syntax highlighting and path information through a particular finding. That allows you to go from the reported warning all the way back through your code visually to see where the root cause of the problem is. You'll also be able to hover over elements in a warning to get deep insight into that particular thing and get it cross-referenced so you know where it was defined and where it's getting used. That gives you the ability to understand the importance of a particular problem and also the cost of fixing it. As well, the hub, the web-based user interface, is also the way that we interface out into your CI/CD system. So there'll be integrations into things like Jenkins or GitLab or GitHub or any of the other CI/CD integrations that CodeSonar provides. And then finally, the idea here is to make this as easy as possible in 27 for people to adopt. So things like, a simple user interface where you say, CodeSonar analyze, pass your GPR file, we will invoke Gnat SAS for you and ingest all of those results into the hub without you having to change your entire way of work. So you'll still have GPR project files, you'll still have LKQL rules, so that the transition should be as smooth as possible for a team ready to adopt. And my colleague Guillaume will be joining me now on stage to do a live demo. So as I said, fingers crossed.
Hello everyone. I'm going to demonstrate what Sean just mentioned. Give me 1 second to share my screen. Okay, so hopefully you should be seeing it now. If that's not the case, you can let me know. So here on the left side you see CodeSonar Hub, which is aggregating and displaying projects and analysis information about your code base. On the right side I have my command line interface, so I'm going to run CodeSonar and some arguments, and in the end I'm specifying a GPR file to this command line. CodeSonar is going to run Gnat SAS in the background, launch it, and import the analysis results into the hub. It doesn't take long because it's a small project, and I'm using incremental analysis from Gnat SAS, and so here you can see that the hub is analyzing, and it actually finished importing the results. And now in CodeSonar, I will display it full screen. You have all the warnings that were found by Gnat SAS that are listed. They get some scoring. This is work in progress, so everything is not completely tuned and adapted, so scoring will evolve to get more precise. And you can see that some warnings have different significance, security, reliability, and you also get to see files from the code base, procedures, for every information that is available in CodeSonar for other languages. When you click on a given warning, you can see the location in the editor or an excerpt of the editor. and you can see the content of the warning. There is some syntax highlighting, and there is also some cross-referencing information that is available in this window. So, for example, the token, the identifier word is defined here, is read in these instances, and you can see all other usage and definitions of such tokens. You can also browse the code like this and see in other places where there will be various warnings for related to this code. When there is some chain of events, you can also see the warning instance and the various events that are displayed in the CodeSonar hub. So that will be it for this demonstration. Thank you.
That was fantastic. Well done. I'd like to welcome my colleague Tony to the stage and hand the floor over to him.
Thank you, Sean. Let's talk about Spark. Spark is deductive program verification for Ada. So with Spark, you get two things. You get an Ada-derived language that comprises a functional specification with subprogram and type contracts, joined to an imperative programming language that's essentially Ada. You also get a tool that performs deductive verification. The Spark tool takes Spark code, annotated with contracts, and extracts a set of logical formulas that we call verification conditions, and sends these to automatic theorem provers for proof. When all the verification conditions are proved, you know that the program and its contracts are correct. There's a lot of great things that we've added in Spark 26. So we're giving you more precise handling of low-level code. For example, we have bit-precise handling of unchecked conversions and sound support for overlays. This is cool because now you can take a buffer of binary data and you can reinterpret this as an Ada structured type, a record, and Spark will be able to reason about that conversion precisely and tell you that it's safe. We're also making Spark faster and easier to use. We're exploiting more parallelism to get more out of your available cores. We're giving you deeper integration into VS Code. And we're extending our support for explain codes, which give you messages with more extensive explanation so that you can dig deeper and understand what Spark is telling you. That's something we're planning to exploit even more this year. We're giving you new contracts for richer specifications, multiple levels of ghost code, which I'll talk about more in a moment, but also support for potentially invalid objects. So now, if you have some object that might be invalid, for example, because you're converting an integer from a string, Spark gives you a precise way to query its validity and then assume that validity for the rest of the subprogram. We're giving you better support for abnormal subprogram termination and making it possible to use functions with side effects in more places. We're giving you better Spark-compatible libraries, more precise contracts on the Ada standard library in input-output and strings, and we're expanding support for SparkLib in containers, lemmas, and C strings. The C string support is especially cool because this makes foreign function interfacing better. So let's talk some more about multiple levels of ghost code. So some Spark contracts can be executed at runtime. For example, we might want to keep around our preconditions because preconditions represent defensive code. This is especially useful if we're doing foreign function interfacing, either from C or even from Ada. Normally, Spark will prove at the call site that the precondition is met. But if it's outside of Spark, it can't do that proof. And so you would want to know at runtime that the precondition is met since the validity of the proof rests upon that precondition. There's also the possibility for dynamic verification. So you may choose at test time to retain elements of your postcondition to ensure that assumptions that were made in the proof still hold. Now, some Spark contracts are not suitable for execution. We have some complex data types, for example, that have very expensive contracts that are difficult or very costly to execute. Lemmas also represents bits of reusable reasoning, and for these, it's often unsuitable to execute these at runtime. Today, this is an all or nothing kind of approach. You have to keep all of your ghost code or none of it. What we're bringing to you in Spark 26 is the possibility to assign assertion levels to contracts, assertions, and ghost entities. And this gives you the ability to determine whether each level is executed or not. So you can define your own level, for example, gold, and we give you a couple of levels, runtime and static, that are predefined. Runtime is always executed, static is never executed. You get to decide if gold is executed or not. On the right, I have an example of a sort procedure. And for this procedure, what we've done is we've said the precondition we want to keep around at runtime. We always want to check the precondition for this sort procedure. So we've assigned the runtime level. For the sortedness property, we've marked this gold. At test time, we might turn it on, and then at release time, we might turn it off. But the permutation check, which shows that the output of the sorting routine is all and only the elements of the input, that's actually very expensive to execute. We don't ever want to execute that, neither at test nor at release time. So we've marked this as static. So these are multiple levels of ghost code, which are present in Spark 26. And that's what I wanted to share with you about Spark. Now, before I get off the stage, I'd like to tell you about one more thing. I'd like to introduce to you Gnat IQ. Gnat IQ is AdaCore's AI-powered chat over our documentation. So we take our user guides, the Ada reference manual, and learn.adacore.com, and we give you an AI-powered chat interface where your questions are answered based on those documentations with citations. So if you ask a question about the Ada language, Gnat IQ will answer the question, and it will give you citations into the user guide or likely into the Ada reference manual so you can follow up, learn more, and also make sure that the chatbot is telling you the right thing. This is integrated into Gnat Tracker, and it's available today for everybody who has an AdaCore account. We encourage you to use this to ask questions about how to use our tools, how to generate command lines, and even things about how to use elements of the Ada programming language. This is not meant to replace our expert support. We love your tickets. We want you to keep opening tickets. Please, it's one of the great ways that we're able to hear from you about your experience using our tools. But we know that sometimes you just want a quick answer. You feel like it should be in the docs, and you don't know how to find it. Gnat IQ is a perfect way to answer those kinds of questions, and I hope you enjoy it. That's Gnat IQ. Now I'll pass the mic off to Walter, who will tell you about GPR Build 2.
Yeah, thanks, Tony. Hi, it's great to see everyone on the webinar today. My name is Walter Capitani, Head of Product at AdaCore, and today I'll be speaking about new and upcoming features in the Gnat Pro tools. So let's jump right into it with GPR Build 2. So GPR Build 2 is our new and improved build application, build tool. It offers improved performance, better error messages, and a more modern architecture compared to our legacy builder. Some of the benefits include detection of potentially ambiguous constructs in your project files and better diagnostics to debug these issues. It also includes new heuristics to determine when a particular source file needs to be rebuilt, which will improve build performance. We've developed this latest version of GPR Build with developers in mind. There's full diagnosis and debug tools and an Ada library included, so you can build project-aware programs if you wish that can read and write GPR files. So we'd like to encourage everyone to give GPR Build 2 a try. It's now included in 26 release. We intend to make this builder our default builder in Gnat Pro 27, so we'd love to get your feedback on how it's going. Next, I'd like to speak about some IDE improvements that are coming in, that have been released in 26. In the last year, we've seen a lot of interest in using Visual Studio Code from our customer base and in the market in general. So we continue to invest and put effort in improving our Visual Studio Code extension to support the same capabilities that are found in Gnat Studio. We've also decided to update our release scheme for IDEs by publishing a new release every quarter. This will allow us to bring new features to the market more quickly, as well as bug fixes, and puts us in a better position to support OS and have better OS compatibility and compatibility with other tools on a more regular basis. At AdaCore, we also will continue to make sure that you can upgrade your IDEs without having to change your compiler change. When it comes to Spark support, we've improved the support in the VS Code extension. You can see here we've added the ability to launch Gnat Proof from VS Code. We're leveraging the VS Code Serif viewer to provide a detailed view of error messages and diagnostics in the tool. We've also added a new VS Code visualizer. You'll see on the next slide. This visualizer displays code information as interactive graphs. So for example, you can trace function references and type hierarchies in any language supported in VS Code with LSP support. We're also, for ADAs, particularly showing file dependency graphs and project dependency graphs. These graphs support zooming and folding. You can search them, and you can also export them to images. We've also introduced Alir Pro. If you're not familiar with Alir, it's a package manager for Ada. Alir Pro is targeted at private source development. This means you can create your own private index of packages, but also can include open source crates from the community. The access to Alir Pro is available on request via Gnat Tracker, and it also comes with Gnat Setup, which is a tool to help install the AdaCore tools using a package manager approach. Looking forward to 2027, there will be programmatic access to Gnat Tracker downloads, so you can download those from Gnat Tracker using Alir Pro. We also plan to introduce SBOM generation on the packages you're using in your project. So now I'd like to talk about some upcoming enhancements on the next slide. So first of all, with GTK Ada, we're planning to upgrade GTK Ada to GTK4. This will improve our support for future platforms and display layers. I'm glad to see that reaction. The good news is, as we did during our previous GTK transitions, we will provide transition guides and help customers via support as they do this transition. We're also planning to upgrade Gnat Studio to GTK4 during 2027. We also received feedback on the initial launch of Gnat Format, particularly requests for more configuration options. As a result, we've added an option to output a tall layout, meaning that instance parameters and other constructs in subprogram declarations will be limited to one per line. We're also excited to provide full configuration for the display layout using JSON configuration files. And on top of that, this customization feature is what we call officially supported, so we'll be happy to help you through the support channel if you have issues developing those JSON files. Last but not least, I'd like to talk about an introduction to Gnat Polyglot. Gnat Polyglot is multi-language binding technology that we've released as a beta this year. It's designed to facilitate multi-language application development by automated generation of bindings to calls Ada code from C++. So if you are an existing customer and you'd like to try this out, you can register for a beta via Gnat Tracker. The basic benefits of Gnat Polyglot are to reduce the effort associated with multi-language programming. It generates idiomatic code, so your developers and users will see familiar APIs and familiar code on both sides of the binding. Finally, by automating this binding generation, it reduces errors and helps keep your APIs up to date as things change. We are looking for users to join our Gnat Polyglot beta program. We'd love to hear from you, so please reach out. There's a link on the screen, or you can find a registration link on the AdaCore website as well. Now, I'd like to introduce my colleague Olivier Hanley to speak about open source and academic programs.
Hey, Olivier, your audio is really bad. So why don't I take over and I'll deliver these two slides for you. So sorry, people, we are having a bit of a technical challenge here. Olivier's audio is really, really bad. So what Olivier is talking about here is AdaCore's strong contributions to open sourcing community. As people probably know, we've been working with Rust, the Rust functional safety team on getting Rust certified for the various different functional safety standards. So that's ongoing in the background. Really, really excited to see that. And then as Tony just announced, we have a crate for the AMD UltraScale Zinc MP. We've also done a lot of work in the typical projects that we work in. So we've made LLVM21 available for GNAT. And then you can see here the list of other projects that we have either committers for or maintainers for: QEMU, LLVM, GCC, GDP, including Ada and Rust. Lots of different investments going on in libadalang, Spark, and for VS Code extensions, as Walter also mentioned. And then we've been working on a self-update framework for Alere. So Alere can update itself. There's a framework for testing that we've just released as part of Alere as well. And a lot of things have been going into Alere from a quality of life perspective, both from using Alere, but also from using the Alere crates on various different boards. We've released the bare metal BB runtimes as well that has support for a number of different maker type embedded boards. We're doing a lot of work here as well with the community on LLM-driven Ada Spark authoring. Right? Many people are looking into AI and LLM to generate code for them. The various different LLM vendors are actually very good at generating Ada code, very good at generating Spark code, and we're working with the community to come up with a good way to evaluate the quality of that code that's being generated. And then one of the things that Olivier is spending particularly a lot of time on is GNAT Academic, right? AdaCore supports various different capstone projects. There's a list of capstone projects here that he's been working on. There's a neural processing unit, Ada driver, a mini rocket, various different satellite programs, both CanSat and CubeSat, where he's guiding teams at various different stages. There's actually a couple of really nice blogs in a blog pipeline right now, where we'll talk about these projects as much as we can. So go to our website under the blogs and as well as under the academic program, and you can find more on this. We're always looking for more ideas. So if you're working with academic projects and you want to reach out to us, please do. You can reach out to Olivier, or there's a form on our website that you can fill out. Very happy to work with additional teams. One of the other parts that the team is working on is a text user interface. There's a little video here, which I think is particularly interesting. So a very simple Ada-based user interface that allows you to add a simple user interface to your text-based projects. There's an MCU-based USB to serial bridge, so you can actually work on debugging your embedded boards better. And there's work ongoing on a game engine library. So lots of different things on helping students use Ada and benefit from the strong engineering principles in Ada for their final capstone projects. All right, so that's the content for today. Some more information here if you want. The QR code is there. If you are more traditional, the link is there as well. If you want to dig deeper into any of these topics, feel free to reach out to your AdaCore technical contact. Feel free to reach out to customer support. We're always happy to talk to people about these topics, as you know us. So please don't be a stranger. The poll results are on the next slide. I think my web browser needs to be refreshed. So we'll get the poll results on you in the slide deck that we will send out. So if I look at the results here in my little screen, so we had various different languages that people could select for what programming language they're using in 2026. It's no surprise that Ada is, of course, top of the list with 29%. The second one may be surprising, Python, though everybody uses Python somewhere in their software development lifecycle, of course, right? And then the next language as I go down the list is, as you would expect, C and C++. And then Spark and Rust follow on before we go into languages such as Java, C#, and unfortunately nobody was using Kotlin in the audience. So let me see if there's any questions that we can answer for you today. Let's have a quick look. There were some questions that were already answered by the team live, but all this panel should be coming online here.
I'm happy to take the ARM32 question, Mark.
Thank you for volunteering, sir. Go ahead.
Yeah, so somebody asked, Louis Etienne asked ARM32 bits. So this was asked in the context of Rust. So for Gnat Pro for Rust 26, that particular tool chain was not released with 32-bit support. However, we are working for Gnat Pro for Rust 27 to make one of the off-the-shelf ports ARM 32-bit. So that is coming, so you can expect it in Gnat Pro for Rust 27. If this is a pressing commercial need, as for any port, please reach out to your account manager. We can support you with a custom development contract. We can tell you a concrete timeline in which to get this port into your hands, and then you'll have early access to it and then full support going forward.
Perfect. Thank you very much, Tony. Any more questions that people have, feel free to shoot them into the question box, and we are happy to answer them. I'll give everybody a couple more minutes to shoot questions in there.
Well, there's also this one, which is for me too. Can GNAT-IQ be deployed onto a closed network? So GNAT-IQ is a software as a service. It's on GNAT Tracker. That's the way it was designed. Certainly, if deploying GNAT-IQ on a closed network is something you or your organization are interested in, you should reach out to your account manager and we can have that conversation. It is not something that we're currently offering. It's certainly something that we would be happy to discuss.
Thank you, Tony. And one of the interesting points that we discovered as we were prepping GNAT-IQ for release, and we've been beta testing it for a while internally, of course, you can actually speak other languages to GNAT-IQ, and it will answer you in that other language. So I asked a question in Dutch, and it actually gave me pretty decent, grammatically correct, full sentences answer with the Ada context in Dutch. So if English is your second language, feel free to give GNAT-IQ a bit of a challenge and ask your question in any language. We tested Dutch, we tested French, I think. I'm not sure what other languages that we did, but there was quite a few languages that we threw at it. Okay, the next one is also for you, Tony. You're muted, Tony. Tony, you're muted.
Still muted.
Apparently Livestorm puts up a dialogue when somebody tells you that, so you can't even click the microphone button anymore. My apologies. Let me try again. We designed GNAT-IQ to be model agnostic, so it's not tied to any particular LLM. If you have a specific question or a specific concern about particular models that might be used, I invite you to reach out through GNAT Tracker to a customer support person or through your account manager.
There was a question in the poll about the new Ada language features that I presented at the beginning of the webinar, and the question was about whether they are GNAT specific or they are part of the ISO Ada language. In this, all the examples that I showed are at least so far GNAT specific. They have been developed either because some customers ask for it, or because we, AdaCore, believe they can be useful. So the idea is that we create that, we make it available to all our customers and users, and eventually if we all find that it is something useful, that is something that can be submitted for inclusion in the next ISO standard. So, but as of today, they are GNAT specific.
Perfect. Thank you very much for that, Jose. Walter, do you want to take the question on Polyglot?
I will, yeah. Thanks, John, for the question. So, yeah, there was a slide on GNAT Polyglot, so it went by pretty quickly, so you can see it in the recording for sure. I will say from a language support, our current language support is to generate C++ to Ada bindings, so to support primarily calling calling Ada, from C++. You asked about roadmap plans. We do have plans to extend both sides of our polyglot technology. The way we've architected it, we can more easily add additional languages. So we definitely have, on the calling side, after C++, we do have plans for Rust and other languages. And certainly from Ada to C++ is also something we're considering. So the reverse direction of what we've got today. If you want more information, or for sure, if you're interested in the beta, please reach out. Love to speak to you and hear more about what you're looking for.
Thank you, Walter. Great questions. Keep them coming. We got a couple more minutes left, so let's just keep on going down the list, team. GNAT IQ for GAP. I'm not quite sure who can answer that question.
I will say that GNAT IQ requires a GNAT Tracker account. So if you have a GNAT Tracker account as a GAP member, then the answer is yes. And if you do not have a GNAT Tracker account, then the answer is currently no. Certainly that's something that we could look at if we need to.
Yeah.
Olivier would be your point of contact for that.
Yeah, Olivier and I, we'll talk about that, and we'll get back to you with a more detailed answer. Thank you, Tony. Fantastic. And then there's a question on GPR Build 2, which I think will go to Walter, maybe, who is muted.
I might defer that one to Jose or Tony.
Yes, I can give an answer to that. So Spark GPR Build 2 supports the GPR syntax that you have in the previous GPR Build technology, so that is supported. It will probably evolve into GPR Build 2 specific syntax eventually, but so far you can use them one or the other with the same GPR files.
Fantastic. Thank you very much for that, Jose. So with that, I think we're close to the end of our session here. We've gone through our questions. If there's anything that, again, that comes up afterward, if you want to ask a question, feel free to send that to you. I'd like to thank everybody again for your attendance. I'd like to thank the panels list for the detailed presentations, and have a great day.